Alright folks, I am watching myself write from a few years ago. I realized that the audio sound is horrible on this video, and so I am using Screencast-O-Matic to create a new video and about standard deviation and variance. Okay, so you have two data sets here. I'll pause this for a second. Two data sets, they both have the same exact range. So you can see that the Macaws and the Sweet Dreams, these two different basketball teams, have the same range. They also have the same average of 74. But you can tell that there's a drastic difference. One is very concentrated around the average of 74, and one is pretty spread out, both at the high end and the low end. Okay? So there has to be some way we can describe the spread of the data. You can't just look at this and say that these two data sets are the same because they both have the same range and the same mean. Something has to be different. Okay, so let's see if I can continue and see where we go with this. And I wonder if I paused too long in the video. And can I? It'd be really cool if I could jump ahead. Probably set all those same things here with the pen pointing all over the place. Okay. Now, calculating variance and standard deviation. Yes, there's an exact way to do it. Yes, you can follow through all these steps. Now, it would be really nice, though, at this point, you can do this all by hand, and I will probably talk you through an example by hand, and maybe I'll do it in this video, I'm not sure, or maybe we'll do it in class. Most of the time, we're going to use our graphing calculators to calculate standard deviation and variance. That one bar stats thing is really going to be your friend. But, so for instance, what I just wrote right there was x sub I minus x bar. That's a distance. Okay, x sub I represents a data value, and then x bar is a representation of the average. So if you take a data value and subtract the average, we get what's called a deviation. You're deviating from the average. Okay? Now, you want to do that for every single data value. And if we, and it's possible in this video that I'll show you how to use a graphing calculator to do that. Once we find all those deviations, step 3 says that we want to square them all. And then we want to add all of those squared deviations. And then we're going to divide the squared deviations by this value, n minus 1. This is called variance. Now, variance is not going to be something that you're going to do a lot with. It's something, if you take AP Stats, yes, you will use variance because you'll be combining data sets. But we're not going to be combining data sets. We're going to be using the standard deviation to compare different data sets and how spread out they are. And to understand, okay, this data is close to the average, this data is spread out way far away from the average. Okay? Now, basically what we're doing is finding an average for the deviations. Now, I know typically an average for the deviations, you have a bunch of numbers and you're trying to add them all up. So you're trying to find the average, you got to add them all up, divide by the total number of values that you have. Problem is these deviations are positive and negative, and if you add up a bunch of positive and negative numbers, they're going to always end up being 0. So how in the world do you add up a bunch of numbers that always give you 0 and then divide them? Aren't you going to get 0 every single time? It's true. It's true, you get 0 every single time. So that's not very helpful. That's why they end up squaring all the deviations so that they become positive. Because if you have positive numbers, then you can find some kind of average. And of course, this won't make any sense to you. You're dividing by n minus 1. Most of you would say, well, why don't we just divide by n? Well, there's a big, long discussion about that. I'm not sure that you really need to know that discussion right now. And then, of course, course, since they're squared, we will be taking a square root. Let's see if we can get to an example here. Not sure what we're going to find in our little video here. Oh. Nice if we get to an example. Apologize for wasting your time. Trying to get something useful here for you. Find the variance and standard deviation for the heights of the macaws. Okay, now we can work through all these steps, but we show them here in a table format. Okay, so we've got, and so I'm showing you right now, you can put all these values in list 1 of your calculator. Okay. And then in list 2, you can go up to the top, and instead of typing numbers in the list, you can type L1 minus the average, which in this case was 74. What that's going to do is cause all these numbers are deviations. These numbers add up to a big fat 0, which is useless to me. So to get them into a format that I can use, I have to square them. So what I did was I went over to list 3, and I'm telling the calculator I'm going to put L2 squared. Hopefully I'll show you there, but you put L2 squared. I don't know why I didn't write that up there at the top, but I didn't. Okay? And then you're going to add these values together, and then you divide by, and then you divide by, instead of 10, you divide by 9, one less than that, and that gets you what's called variance. Then if you want the standard deviation, it's 3.77. You take the square root of the variance. So that's the relationship between variance and standard deviation, and now I have no idea what's going on. Okay, so now I'm showing you the nasty, ugly definition. Please, 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 please do not think for a moment that I'm having you memorize that at all. Okay? It's programmed into your graphing calculator, the one that you should have already purchased, so that you can be using it. Okay? But we can walk through what I see here. So in other words, there's a data value minus the mean. So this is a deviation. Remember, the sum of the deviations ends up being 0 every time, so we square it to make them positive. Then we add them all up. Once we add them all up, we divide by n minus 1, and that gets me what's called variance. S squared, they use the letter S squared for variance. And then when I take a square root, I get S, which is the standard deviation. Now, truthfully, this is the standard deviation for a sample. Lots of times we use samples. But if we ever do get, and right here obviously I'm writing out that, what in the world can I spell 1-bar stats? Gee whiz, it's terrible. Okay, we use 1-bar stats in order to come up with this value much quicker. And if you find S sub x in your 1-bar stats list, that's what this is, and it is the standard deviation for a sample. And if you would have a population where you had all the data values, there is a slightly different formula, and we'll see if I actually show that to you here in the rest of this video. I'm not sure what I'm talking about right now. It feels weird. Why am I not actually moving to something else? Come on. Okay, zoom out. Let's go. So this must be the other team. Yeah, the other team's information. List 1, deviations in list 2. List 3, we square them. Add these all up. Divide by the number of data values minus 1, which would be 9. Mysteriously pointing at find the sum is 740. Wait a second. Oh, I must be missing a decimal or something. Oh, I see. Variance ended up being smaller. Standard deviation was smaller, 2.4 versus the other one, which makes sense because we had this data was that data was much more centered around the average. Here is these are histograms. Let me see if I can get back here for a second and slowly jump ahead. Oh, this is not the greatest thing in the world. Let me see if I can wait till it catches up here. Because I want to look at these histograms. As you can see, it's Friday and I need to take a nap. That's what happens to me on Friday night. Is I go to sleep for about 20 minutes on the couch, wake up, and watch the rest of the. Oh, missed it just a little bit. Okay, here is a distribution of values that's centered around the middle. And when you have that, you will get a smaller standard deviation. But when you have data values that aren't really centered around the middle, then you're going to get a larger standard deviation. Let's see if I show some other ones. Okay, so this must have a massive standard deviation because it is way spread out. Okay, why is that big on me? Okay, I'm back. I think I figured out what was going on. I don't know. Anyway, this is the one obviously with the largest standard deviation because it's spread way far out from each other. Sorry for the yawning. If you're yawning, it's probably, you know what, you're probably the one that's yawning and you're making me do it. Okay. Now, I'm having a discussion here right now because there is a slightly different formula, and this is for populations. If you have all the data, which not a lot of times do we have all the data, but if you have all the data, then you can find the actual variance and standard deviation instead of a sample version. You're going to notice that these formulas are a tad bit different. Right down here at the bottom, they have n, not n, so n minus 1. Okay, that means we can find the exact average of the squared deviations instead of an approximate average, which I'm sure that makes absolutely no sense to you. But when you get into AP Stats, you'll talk about the differences between S and sigma. This is little sigma, by the way. Little sig, as it's known in the rap world. Okay, so little sigma, not the same thing as capital Greek sigma, summation notation, but little sig. All right, and you'll notice in your calculator it'll look like little sigma with an X next to it when you do the one-bar stats. So don't get confused. You got S of X and sigma of X. And I think that's the end of my video. Have a great weekend. Or whenever you're watching this video. It's not the weekend. Because it might not be the weekend next year.